Hi, my name is Sonali.
And my name is Sammy.
And our project was creating a robot that can find an exit by creating an escape route and relay those directions to a user. So we found out that after the Haiti earthquake, an additional 25,000 people died every day due to entrapment inside a building, an area, or under rubble. So that leads me to our purpose of creating a robot that can find an escape route or locate an exit and relay those directions back to a user to escape safely from a building or an area.
And to complete this, we created ourselves a series of goals. Our first goal was to get the Scribbler robot to autonomously get through an area, or in this case, a maze. And by doing this, it would use its infrared sensors to detect obstacles that are in its way. And our next goal was to get the path that it took and store it within some sort of data structure, such as an array in this case. We also wanted to symbolize the end of its path or its journey, and by doing this, we used light sensors to shine a flashlight on it, symbolizing the end. And this is just a quick flow chart of how our program works. So it starts by moving forward and then asking itself, am I within a certain light range? If it's not, it then asks itself, is there an obstacle in front of me? If not, it'll continue and move forward, but if there is an obstacle in front of it, it'll stop, adjust its path, and store it within a data structure. It then completes this loop until it gets within a certain light range. In that case, it stores that final data structure and then inverses the path that it took and gets back to the user. And this is just the front of our Scribbler, and here you can see the infrared sensors that we use to detect obstacles. And this is the back, where you can see the 3 light sensors that we use to detect the light.
So this is a sample of our code. On the left side, you can see how we implemented a timer. At the beginning, when the Scribbler started moving first, it started a timer. Once it hit an obstacle and made a decision to turn right or left, it would end the timer. That value would then go into an array where we can access it later. So when we inverse the path, it could then take that value and move forward, turn right, turn left for that same amount of time. So on the right, you can actually see how we inverse the array. For example, if it first turned right on the original path, it would actually change that and turn left when it's going back to the user.
And here's an example of an output that our user might receive on their end. Here you can see the distance that the Scribbler traveled until it met an obstacle. In this case, we measured it in inches. And this was calculated by using the seconds of how long the Scribbler took until it reached that obstacle. Then we also have the direction that the Scribbler took to get around the path, and by the end of it, you have the complete path that the Scribbler took.
This is a demonstration. Right now, the Scribbler is sensing for if there's an obstacle on the right or the left, so it can make a decision on which way to turn. And this is when the Scribbler inverses the path and returns back to where its original spot was. So as we previously mentioned, we want to apply this in a natural disaster scenario. So as emergency response resources are very limited to time and personnel, we want to have this application near a first aid kit or an emergency kit so that's accessible for a user. So once being in a spot where you can't escape or find an exit, you would release the Scribbler, have it find an escape route, and relay those directions back to yourself. Then once the Scribbler reaches outside or hits the light, it would return back to you, and this would increase your chance of survival because if you have fatigue, dehydration, or injuries in a natural disaster, it's very hard to get out of the building, so this would be able to find an exit and help looking at your injuries.
We would also like to make some improvements in the future. One of the main improvements we would like to make is instead of just simply printing the directions out on the screen, we can have it mapped out on something such as a mobile phone. We would also like to send a signal back to emergency responders so that first responders know where and when an incident is happening. And finally, we would also like to make the IR sensors a bit more accurate so that it can travel more accurately and so that the user can have more accurate directions.
Thank you.
Thank you.
Awards. So you may have noticed that 2 of the 3 of our teaching staff have boots. I am the only one without a boot, which is why I have the duties of actually walking up. And so the award, the achievement award for this is the most challenging obstacle course for our cluster gimps.